Welcome to Mastering Innovation Together with Alan Kent and Chris Koomey of Thorben Consulting. And as we talk about AI or artificial intelligence, other things that get thrown in related to that are automation and machine learning. And so they're related, but what's the difference between AI and machine learning?
That's a good question. It's a boundary that often gets blurred when you're speaking to the topics casually. To a degree, it's all buzzwords. So there are different interpretations of it by different individuals. The kind of standard interpretation of the nuances there. Machine learning is kind of the process of training a machine in the arenas of the neural networks and stuff that we've seen. It's taking that data set and defining the process of iterating the model and training it, scoring it, improving it. And that's a cycle that you unleash thousands, millions of permutations and generationally try to improve the model. And so that whole process of starting from a data set and goals and training the machine's intelligence to accomplish a specific task, that generally is referred to as the process of machine learning.
Yeah, and
From that,
machines are always tools. I think that's kind of
yes,
to help us do something.
yeah. And from the process of machine learning, the goal is to produce a model, and that model is now what we refer to as pre-trained. So the process of training that model is very computationally intensive. Lots of permutation, lots of threads, lots of time, typically. The pre-trained model, we have now gotten it to a point where there's a developed neural network that can take a series of inputs, and given those inputs, it can make decisions on how to transform that data and produce a set output. And sometimes there might even be some randomness built into that so that the output's not always universally the same for the same inputs. It might have some variation there. But that now produced model is usually what we refer to as artificial intelligence, where a system is taking input from other systems or from users, sending it through that model to get a transformed output. And so even though it's kind of this static code base that's transforming those outputs, it mirrors or imitates a degree of intelligence that we would inspect. It can kind of fool the human into thinking that, oh, we're talking to another human, or that this output's been produced by a human. And so that's what we kind of classify as intelligence. It seems intelligent to us. It's producing a valuable output. Of course, it's artificial, hence the whole term artificial intelligence.
That's so interesting as we're getting into this new world and we're defining, but it's really just applying similar models, some very task-oriented, some more open-ended, and that's where the AI ML break may be.
Yeah, and what we've kind of seen is the basis that drove machine learning and producing these models is the complex task that you could set a programmer down to do, and you start thinking of edge scenarios on it. Like if we go to Tesla and their full self-driving stack. If you tried to manually code for every single potential interaction that you might see on the road, it would be a never-ending list. And some of those decisions are very hard to hard code to a specific output. It's more of a nuance of you need to take all these properties from around you and make a decision based on that. To be able to tackle kind of these complex problems, that's where neural networks were popularized. Of we aren't going to write the actual code that takes these inputs and tells us what outputs to run. Should we accelerate? Should we brake? Should we turn? We're instead going to build the framework for the neural network and the training data, the scores that tell us how well we're performing, and then we're going to let the machine learn from the data set what works and what doesn't work. And our scores will try to take the output and say, oh, that output will lead to a crash, or that output will lead to a fast G-force change that's going to be uncomfortable to the occupants of the car. And so we can score those badly. We can reward the good output, and the machine is going to learn, okay, based on these inputs, what changes can I transform those inputs to that rewards and the best scores. And so just through permutations and time, we can have the model learn and get to a point that would have taken a human an entire lifetime to have gone through that many permutations of their code. Whereas now we have this processing power, we have the supercomputers that we can throw the model at, and it can churn through a couple lifetimes worth of permutations in days.
Yeah. So never mind 10,000 hours. It's 10,000 lifetimes that you're running through in some ways.
Very much so. And granted, Moore's law is being called into question to a degree of we for the longest time we've had that 2x like growth factor to our capabilities in electronic computing. We're starting to see kind of the limits of that, but we still have the ability to scale that out. And time is one of the most valuable resources that anybody has. And so being able to kind of offload those time intensive tasks of those permutations of that learning off to machine learning gives us the ability to rapidly get to things that would just have taken a unconceivable amount of time to achieve by traditional means.
Yeah, it's amazing. So how are in your work, you're using automation, you're using ML, using AI at times. So how are you applying some of this information, even though it is just in the nascent stages?
Yeah, so for one of our customers, I worked with a background in SIEM, security events, and information management. And part of that's taking all these logs from the different systems, performance counters from the different systems, and being able to alert on potential malicious actions being taken within the environment. One of the huge challenges in that arena is just the amount of machine data that you get. We're starting to lean more and more into automation, which means that there's more processes running, that there's services that are getting spun up, systems being spun up and shut down constantly, and that all increases exponentially the amount of machine data that you get from it. So it becomes something that is hard for a human to consume. And then the pace of iteration on some of the programs, the log syntax that you might get from a program might iterate and change. And so if you're relying on fixed ways to extract value from those logs, a new version might come out and that might no longer work. So one of the practical use cases for us there was in abnormality detection. So you can use all this incoming log data that you have as your training data set for a machine learning, and then producing a model of this is what normal looks like. Train it on what normal looks like. And then once it has that, that model can watch all of the logs coming in and say, oh, here's something new. Never seen this before. Or, hey, this log that normally says like the number of connections from this box is 1,000 connections. Well, all of a sudden it's spiked up. This is unusual behavior pattern. And where that really plays in is when you have a production system that's actually being used, that has a true workload on it. Definitely, if humans are involved in that workload, your access patterns are spiky. They're chaotic. So fixed thresholds don't work. You can't just say, "Hey, if the activity goes beyond this hard-coded threshold, that's abnormal. We need to take action on that." Instead, you have these kind of hidden patterns in the chaotic data that a human has traditionally done a very bad job at being able to identify, but a machine learning data set and approach can actually identify those trends in it and help us achieve something to sift from just this fire hose of data into actionable events that humans or even other services can take those events and say, "Oh, okay, this has happened. Let me do something for it." So it's consolidating down just this wealth of information into actionable and meaningful data.
And it gets to what we were talking about earlier, that there's all this data has existed, but now it's being captured. And it used to be, even if it was captured, no one wanted to do it and actually look at it.
Mhm.
And because it
Yeah,
were people,
capture it for the audit, check the box, and move on. But
yeah,
we've learned there's value in that data. There's so much value in that data from what the system's actually doing, even just from a cost savings perspective of what's going on, and hey, is this actually being utilized? Can we scale to a slightly different box of rearrange more compute, less memory, more optimization on the cost front? So it's so valuable data.
yeah. And most of the famous security breaches where the abnormality was caught, but then people intervened and allowed it to continue, right?
Mhm.
With Target or the Democratic National Committee or whatever, there was always the abnormality was caught, but then people allowed the breach to continue and advance. And I think that's where we're moving away from, is trusting the machines to tell us.
Yeah, getting the human out of the loop sometimes is beneficial. There's a fault with humans to typically be able to try to rationalize things. So yeah, there's this abnormality, but sometimes you don't want to assume the worst, and you take that abnormality and you can figure out a reasonable explanation of why that might have occurred. And so, okay, hey, that seems reasonable enough. I have 10 other alerts to look at. Let me just go ahead and close this alert and say, yeah, it was probably this. If it pops up again, then maybe we'll look into it more. So humans aren't always the best judge on some of that stuff.
You know, rationalization is the most powerful force in the universe, I think. So, Alan, thank you so much for mastering innovation together with us. And we look forward to hearing from you in the future. Thank you for mastering innovation together today with Thorben Consulting. This is Chris Koomey. We'd love to hear from you. If you enjoy the show, if you have any comments, questions, or just want to learn more about what we do. Thanks for joining us.